morning, everybody. So let's go ahead and get started. So what I thought I'd talk with you about this morning is to give you a look at what Azure and Microsoft have been doing with confidential computing. We've been working at it for a long time, and actually it's really exciting and an honor to be up here speaking today because it's literally the 10-year anniversary of when we started a confidential computing program in Azure. So it's been a long road, but we're at a breakout point. And so I'm going to talk about the road that we've been on, what we've got developed, what our partners and customers are doing, and then talk about where we think things are going with confidential computing. So if we take a look back the 10 years, the reason it started is I had joined Azure in 2010, and immediately I started to hear from customers that cloud is insecure. We don't trust putting our data in the cloud. I heard about a research effort going in Microsoft Research, which was looking at using SGX enclaves. And they were doing it for compatibility, an isolated environment that they could provide local code execution for untrusted code with confidentiality on consumer systems. But when I saw that, it immediately clicked that this was a technology meant for the cloud. That if we could isolate ourselves from our customer data, that might be enough to convince people to start migrating to the cloud. And since at that point, we moved part of the Microsoft research team that had been working on this technology, back then called trusted execution or trusted computing, into Azure. In 2015, we published one of the, I think, first early papers on looking at how cloud confidential computing could be realized using confidential computing technologies. In fact, this paper is where we coined the term confidential computing. If you take a look at that abstract, there it is, our first use of it. And this is what we decided we should call this technology because trusted computing is very vague. Confidential computing really captures the essence of what we're creating, which is this black box that provides confidentiality for the data within it. Now, 2019 is when we first introduced confidential computing hardware with Intel, deep partnership where we actually brought in workstation class machines into our data centers. Something we'd never done before because that's what SGX was built on top of at the time. And we continued to work then with Intel, with AMD, and more recently with NVIDIA on driving forward the capabilities of confidential computing hardware. Not just having enclave support, but now having the full support for an entire virtual machine, which also gave us the ability to create confidential containers on top of that confidential virtual machine technology that both Intel and AMD have brought to market. And the exciting thing, and I'll talk more about this towards the end of the presentation, is now we're fleshing out the full end-to-end story. It's not just CPUs, but accelerators as well as the connection between different confidential computing enclaves through trusted connections that are also confidential. Now, one of the things that we also recognize very early is when you take a look at a confidential computing system, it needs to be somewhat automated. You don't want humans there that are looking at the attestation reports and releasing keys to decrypt the data. So what you need are two key services. And I guess that's a pun there. But one of them is the key management service. And the key management service is where those keys to the data are stored. But what causes the release of that key to a piece of code is the attestation service. The attestation service will look at the attestation report from the code, verify that it is actually an authentic attestation report, and then that code can go submit that attestation result in the form of a token typically to the secret manager, the key release manager, which has a policy on it that says only release the key if it's producing an attestation token that is valid and has these properties in it or these claims in it. And at that point, the key gets released. So these were some of the first services that we created in Azure. This is the set of confidential services that we've developed over the last 5 or 6 years in Azure. And like I mentioned, two of the key ones for the confidential, what we call confidential trust boundary, code that you allow into the boundary of your sensitive data, Manage HSM, which is built on top of Intel SGX, and the Microsoft Attestation Service. We've also got compute services, including support for, like I mentioned, confidential containers, confidential pods, confidential nodes in Kubernetes, confidential virtual desktop even. We've got data services like SQL IaaS, like SQL always encrypted, so encrypted SQL engine that protects the confidentiality of the data in the SQL store, in the SQL tables. Azure Data Explorer, which is a log analytics system. We also offer that confidentially, and through a partnership with Databricks, we now have in public preview confidential Databricks for confidential analytics. And then finally, we've got some specialized services. We have an immutable ledger built on top of a blockchain, confidential blockchain technology we've created that's called confidential consortium framework, CCF. And we announced a public preview of that just a few months ago as a managed service where you can build confidential applications, kind of a new kind of data compute application that is confidential, that is built on top of an immutable ledger. Now, let me talk a little bit about the state of adoption of confidential computing. We've been working with lots of customers, but I want to first talk about what we're doing internally at Microsoft, because this is the breakout moment for confidential computing, not just for the industry, but for us in Azure and inside of Microsoft. And you can see public evidence of that. Here in the fall, we announced a new effort called the Secure Futures Initiative. This initiative, which we recently re-amplified, is one where Microsoft, which has always considered security of our services a top priority, products and services a top priority, now has explicitly stated that it is the #1 priority. In fact, Satya is basically said to us, I prefer security over features. And we've got governance in place, we've got pillars, and you'll hear more about this in the coming weeks, about exactly what we're doing and where we are with making our services even more secure. But this blog post from the fall highlights something that we decided to do in response to weaknesses or vulnerabilities that were exploited in the way that we handle our own token signing keys. And this is the key excerpt from that blog post. Protect identity infrastructure signing and platform keys with rapid and automatic rotation with hardware storage and protection, for example, hardware security module, HSM, and confidential compute. We are rolling out confidential computing hardware around the world, and all of our identity systems, our key token services, will be running in confidential virtual machines. Also, we, like any other enterprise, have workloads that we have considered too sensitive to move to the public cloud. And part of that is that we've created isolated, high security environments for these services. One of them is our payment processing services. And I've been working with that team over the last few years on designing an architecture and an execution plan to move those systems into Azure. What's made it possible for them to actually move it into Azure is confidential computing. And we achieved a key milestone here just a few months ago, which we've got announced in a public blog post, that we finished migrating our credit card payment transaction services, which have to be PCI compliant, but where confidential computing is not yet, but we expect will be a regulated requirement on PCI, into confidential computing. And that has allowed us to move that workload into Azure. We're also in the process of migrating our key signing services code signing services and artifact signing services into Azure. And there's several of them that we have with different degrees of sensitivity and complexity. But again, the only reason that we're now getting comfortable doing that and putting it in a shared environment like public cloud is because of confidential computing. Now let me talk a little bit about some ISV examples. Beekeeper AI, a company that was a startup that was spun off of University of California, San Francisco Medical Center, focused on healthcare, collaborative healthcare scenarios. So kind of creating clean rooms where different healthcare data can be brought together and then analyzed. Habu is a company that we're closely partnering with. Again, also another one that is focused on taking multiple data sets from different entities, merging them together, performing analytics on them in a confidential computing environment. Edgeless systems, again, also looking at bringing multiple data sets together, also just providing confidentiality of single party workloads. And then, of course, Opaque, our sponsor, which is also very focused on taking and having these multi-party computation scenarios. You see a theme here. Really, when it comes to confidential computing, there's defense in depth, examples of some of the things we're doing internally at Microsoft. There's keeping data away from your own employees. And then there's also the multi-party computation, which is a very exciting area where you can bring different data sets together, not share it with the other parties, but share it with the code itself. Now, let me talk about some of the ISVs that we're directly working with, because all of customers. Those ISVs are all working with their own customers in their own scenarios, but I'll talk about some of them that are working directly with Microsoft. One of them is RBC, Royal Bank of Canada, and this one we've been working with for like 5 years. They came to us and with a vision. They'd heard about confidential computing, the fact that we were working on it, and they're a credit card issuer. So they work with consumers and merchants. And their idea was, hey, looks like confidential computing would be great for our loyalty programs and ad business. Because what we can do is take, for example, the merchant history, which has exactly what a consumer's purchased, our view of credit card transactions, which spans all merchants, but we don't know exactly what those transactions represent. If we could merge those together, we could actually get a very in-depth, detailed view of what a consumer is doing. So for example, if somebody went on a trip to Italy and they went to the local store before they left, and they purchased a number of items to travel with, by merging those data sets together from the merchant and the credit card transactions, you would know this consumer buying habits. And so the next year, when they go take another trip and they go back to the same store, by looking at that history, merging that data together, you can provide very targeted offers to that person as they're going around through their shopping experience and give them offers that exactly might be things they're interested in. But the key point is that nobody's privacy was violated. The merchants can't see what the consumer did. The bank doesn't know exactly what those transactions were. And the consumer gets this very targeted experience when they're shopping. This right here is the future of advertising. And I think advertising actually was represented with RBC, which is going to production with this, with they've got a couple merchants signed up and they're going to sign up several hundred over the next, towards the end of the year, is actually the first step where you're going to see regulators come in and say, advertising needs to be confidential because of the sensitivity of this data. Another example is Swift. So in the financial sector, we partners with Swift, and again, very multi-party scenario. You have regulators that are looking for fraud, or banks that are looking for fraud, but don't want to see all of the individual transactions, of course. They want to look for anomalies. And this is a great example where confidential computing can make it eyes-off analysis in detections for fraud. Fireblocks is another example. Digital wallets, which hold keys to literal kind of assets that have value. We partner with Fireblocks, and they've got more than 100 million digital wallets stored in Azure. And of course, stored in Azure makes it more reliable than just stored on your phone, because or your server. If those things die, if they fail, if they get stolen, you've lost your assets. Storing them in the cloud, but confidentially, preserves their privacy, but also makes them reliable. And then finally, how many of you use Signal? Because I know a lot of people use Signal, especially security researchers. Signal itself for messaging provides end-to-end encryption. So no data is ever clear on any of the stops and the nodes that go through cloud services, for example. However, there's a lot of metadata that goes along with those conversations. Like if there's a multi-person chat, for example, who are the parties in that chat? That data, while not actually the data of the conversation, is also security sensitive because you can look for patterns, who's talking to who. So partnering with Signal, they're running and protecting their metadata for those conversations with confidential computing in Azure. And then confidential computing is already having an effect on our bottom line. We're already having customer wins, major ones, because of how far we've come with confidential computing and the story we can tell around it. And I've got a couple examples here. This is specifically, if you take a look at governments, foreign governments outside the US, very concerned about the privacy and control over their data. We call this data sovereignty. And we've already had several wins where working with system integrators in countries with governments where we've won deals to create sovereign clouds for them based on confidential computing. Leonardo with Italy and the Italian government is one example, and Proximus is another example. And you can see here, this is building on technical innovations from Microsoft like Azure Confidential Computing. This is a quote from Proximus that directly led to this deal for a sovereign cloud. Now, I want to stop and talk a little bit about where things are going. And there's a couple things I'll talk about when looking forward to the future. One of them is at the verge of what we're on with the release of H100 confidential GPUs. These H100 confidential GPUs, our engineers in my confidential computing research team co-designed the confidential computing capabilities into the A100 as a first step, and now the H100 as a complete step for confidentiality. So this, like I said at the beginning, completes this end-to-end picture. It's not fully fleshed in yet because we don't have confidential communication between these two, so there's still some friction and overhead on the communication to make it secure that hardware will address in the next year. But you can see here, we can have a confidential virtual machine that is, for example, managing the inputs into an AI application, sending those inputs encrypted into the GPU for processing, taking those results back out. And again, everything is protected with confidential computing and the keys that were released because of attestation. And when you take a look at the promise of this, and I looked at the agenda for this, for the summit, and there's probably a dozen talks on confidential AI and confidential generative AI. So I'll just briefly talk here about the different ways that confidential computing intersects with AI, really creating a breakout moment. It's kind of like the hardware has arrived just at the right, confidential hardware has arrived just at the right time as AI is exploding to create this as the perfect accelerant for confidential computing. One of them is the protection of the model. A lot of customers are creating their own domain-specific models, and they're spending millions, tens of millions, or even more dollars training these models. And they want to protect that IP in that model. They want to protect it from all of the things that Raluca talked about, all the potential threats that confidential computing can defend against. Confidential computing is a great way to have those models protected end to end. And then protecting the data, that data that went into training those models, whether it's fine-tuning the model, creating a model from scratch, pre-training it, is very sensitive as well. By definition, if you're creating a sensitive model, the data that went into it is also very sensitive. When with confidential computing, you can make that data available only to the AI training job. And then when it comes to inference, and I think inference is the number one killer scenario right now because it is a fairly simple one with very visible benefits. If you consider, for example, confidential speech transcription or speech transcription, you're sending speech into a model and it's translating it into text. Well, speech happens to be some of the most sensitive data of any enterprise. The speech and the text, resulting text from that speech, can literally move markets if it falls into the wrong hands. And so many customers are concerned with doing speech transcription in a public cloud service. But with a confidential speech transcription service running in confidential VMs and CPUs or GPUs, the customer can send their encrypted prompt right into the cloud and get back the encrypted response with none of the outside environment other than a confidential computing one having seen it. And then finally, I've already talked kind of at length about multi-party computation. This is a very exciting scenario as well because it opens the door for parties to share data together and get analytics or AI insights out of it that just wasn't possible before. So I've got a quick demo of confidential RAG, a real world example of showing where we are with this technology. In this case, we've got a website here, and there's the attestation report for the CPU on the left and the GPU on the right, confidential H100. Now I want to configure a policy for myself where I trust those attestations. So I look at them, I look at the SVNs of the firmware, the versions of the hardware, and I say, create a policy that shows that I trust this so that I can see when I'm interacting with something trusted. Now, this is running a model with a vector embedding database. And you can see now that I've set that policy and refresh, this shows that the site is completely trusted. So at this point, I feel comfortable sending in a very sensitive prompt. What is confidential computing? And you can see that this model is a little lame, doesn't know what confidential computing is. So what I want to do is teach the model what confidential computing is. And for that, I'm going to upload a document, create embeddings from it, store it in the vector database, and that is done completely confidentially. I give it to the confidential VM, it creates embeddings, stores it in its slave database, and now when I say, what is confidential computing, it gives me back the answer that I would expect. And again, the document was never seen inside the cloud. This prompt and the response was never seen inside the cloud. Now, the one thing just to show what happens if something changes. What if the hardware version changes? Or what if I change my policy about what I trust? I'm going to go just modify here the attestation report to show a different driver version, or say that I want a different driver version rather, and that doesn't match what's actually running in that GPU at this point. And so at this point, the attestation fails, and I see that I can no longer trust this site, at least given my policy. So there's an example of RAG with confidential computing. So the last thing I'm going to talk about relates to this question of what is confidential computing really? Because I think many customers view it as I have complete control over what touches my data. It's my code and my data, and it's sitting inside this confidential trust boundary, we call it, CTB. But unless you're talking about IaaS only, and the customer bringing everything themselves, and even then, can they trust all the code if they've got millions of lines of libraries and frameworks? How do they know it's trustworthy? Well, they've decided to trust it and brought it into their CTB. But even more importantly, what if they bring in a service that is managed and updated by somebody else? Should they trust that? How can they trust that? And this is external services. This is very relevant for cloud computing because you're not going to get the power of the cloud without cloud services for your code and data to rely on. So we've been thinking long and hard about this and realized that confidential computing isn't about control. It's about guaranteed auditability. And so we've written this paper that in the communications of the ACM, we led the creation of a series in communications of the ACM of special issues on confidential computing. The second one is out right now in CACMQ. This article is from the first one from September. Why should I trust your code? Which looks at this very question. How do you trust bringing somebody else's code into your confidential trust boundary? And what we concluded is that we need to build the root of trust for a confidential computing system that we call a code transparency service. The code transparency service has policies on it for what code can run in the CTB. And it issues signatures for code that meets that policy. Now, once code can meet this policy and you can set the policies up appropriately, and I'll talk about the policies in a second, then you can have an autonomous system that is continuously upgrading itself, always guaranteed to offer somebody that ability to audit what exactly touched my code. If I believe my trust is violated, how can I go and verify that? And the answer to that comes with an immutable ledger we're building on top of the CCF framework, a confidential signing service, which has, as part of it, coming in a policy that we believe is the fundamental one, which is reproducible builds. The code has to be reproducible buildable, and you've got to have escrowed the artifacts that went into that build. Escrowed in a way that's out of the control of whoever's running those confidential services, such that if you believe your confidence, your trust was violated, you can go and say, I can produce the artifacts, I can reproduce the build, tell me, and I can look at the ledger to see what exactly was running and see now a match, which means I can go look at that code and determine if there's a backdoor or a vulnerability that might have exposed my code. This is the only path to scalable confidential computing. And once you have this, like the code transparency service says, artifacts are escrowed, build is reproducible, and I got that from a trustworthy and a tested confidential reproducible build service. Now I can issue a signature that will allow, for example, code transparency service itself to look at an upgrade package and say, should I upgrade this? Well, does the code match the policies that are set from upgrades of myself? How do you bootstrap the CTS, which is the root of trust now? You bootstrap it with policies and review of the code by, for example, an auditor. And that creates the root of trust for the whole system. So this is the new root of trust for, we think, the future of confidential computing. So let me just close by talking about the fact that we've been at this for 10 years. It's really exciting to me to be here at a confidential computing summit now. And this is the breakthrough moment. There's so many things coming together right now. The confidential hardware, the confidential services, the maturity of the services and all the domains that I've been talking about. We're in this at the beginning of the takeoff. And we're not quite there yet, but in the next 2 years, we will be, because some of the limitations with, for example, GPU scaling to support training at large scale confidentially, for us to be able to live migrate confidential virtual machines so that our customers aren't impacted with confidential computing in a way that they're not with general computing. Having confidential hardware, confidential VMs, be able to sit side by side in our clusters with general purpose VMs rather than in separate clusters, which was what we've had to do up until now. All of this is being realized in the next couple of years. And then at that point, we'll be realizing our vision of pervasive, ubiquitous confidential computing in Azure. We will become a confidential cloud, and that's our ambition. You're going to hear us talk a lot more about that ambition, but that's where we're going. So with that, I want to thank you very much. It's been awesome being up here to share this story with you.
Thank you.